Let's talk about the very first step in linear least squared regression. Remember, least squared regression should only be used if the relationship between two variables is linear. The first thing we should do in deciding whether we think that there's a linear relationship between two quantitative variables is to look at the data set. How can we look at the data? We do a scatter plot, which is nothing more than a graph of the paired data values x, y, and the xy plane. Y is our response variable. That goes on our y-axis, and x is the explanatory variable, and that goes on the x-axis. So before plotting it, you have to decide which variable is your explanatory variable and which one is your response variable. Here we have a table with some data in it. The data represents the heat index, or the apparent temperature, versus the relative humidity in an environment whose actual temperature is 85 degrees Fahrenheit. So if we were in a room that was 85 degrees Fahrenheit and the relative humidity was 50, then the heat index would be 88. We want to see whether regression, least squared regression, is appropriate for these two variables x and y. Is there a linear relationship between these two variables? We first must identify which variable is our explanatory, or x variable, and which variable is the response variable, or the y variable. We want to be able to predict the heat index given the relative humidity. So the relative humidity is our explanatory variable, and the heat index is our response variable. When we plot our data points to see whether there is a linear relationship between those two variables, we want to put the explanatory variable, the relative humidity, on the x-axis, and the response variable, or heat index, on the y-axis. Make sure you always label your axes. We have relative humidity measured in percent, and we have the heat index measured in degrees Fahrenheit. Now we are ready to plot our points. We have the relative humidity going from 0 up to 100%, and we have the heat index going from 78 to 111. Notice this little jagged part in our scatter plot. That means that there is a break in the scale for that axis. Instead of starting at 0, we are starting at 78. So there was a break, and we have to indicate that in our scatter plot. All right, our first point that we want to plot is 0, 78. 0 degrees relative humidity, 78 degrees for our heat index. 10 degrees, or 10% relative humidity, is a heat index of 80. A relative humidity of 20% gives us a heat index of 82. Continuing plotting all the points, we have the following as our scatter plot. Does there appear to be a linear relationship between relative humidity and heat index? Yeah, especially early on, and before 70% relative humidity, it looks very linear, and it may be linear following that. We need to complete the least squared regression in order to answer whether a linear model is totally appropriate for this data. If we do a least squared regression line model for this data, the least squared regression line would be the line such that the vertical distance between the line and each one of these data points, when you square it and you add up all of those vertical distance square distances together, you get the smallest number. That's what least squared regression does. You can also do scatter plots on the TI calculator. The first thing you must do is put the data into lists. I have already done that. List 1 contains the relative humidity data, and list 2 contains the heat index data. To get the scatter plot, we go to second stat plot, turn on stat plot 1. A scatter plot is the very first of the graphs. We want to plot the relative humidity, which is in list 1, on the x-axis, and we want to plot the heat index, which is in list 2, on the y-axis. We have all of this set up. Now we do zoom 9 for zoom stat, and here is our data on the TI calculator. Again, at the very end, it appears to curve up somewhat. It appears very linear for the low relative humidities, and then it appears to curve up somewhat. But the scatter plot is always the very first step in doing a least squared regression, to look at the data to see if a linear model seems to be appropriate. The final answer as to whether a linear model is appropriate will come after you do a least squared regression. But if you clearly see a non-linear relationship between the two variables, there's no need in proceeding any further.